All right, so we are in our first geometry unit. It's called the Building Blocks of Geometry. This is our first lesson. Basically just goes over terms and notation. So in geometry, we're building off of a lot of different knowledge that we already have. We need to just go over some things just to kind of define what each term or what each thing actually is. So in geometry, there are three things that we consider undefined terms, and these are point, line, and plane. Now we can talk about what they are and what they mean, but there isn't an exact definition for these things because they're pretty abstract. It's hard to physically show or think about what these are because these are technically like in physical things. So let's go over what they each mean. A point is technically just a spot in space. Think of it as a location. It does not have any size. Not have any size. In a sense, it's like the 0th dimension, and I'll go over what that means. Now, if I take this marker and I put a dot right here, we can think of this as a point, but it's not actually a point. It's too wide and too tall to be a point. Now I know it doesn't seem too wide and too tall because it's really, really small, but really a point has no actual physical attributes. It's not wide, it's not big, it's not small, it's just a location, it's just a spot where something is. It's just there in space. And we call it the 0th dimension because there's no place for it to go. Right here, you're not traveling up and down, you're not traveling left and right across this thing. This is literally just the location, so it's in the 0th dimension. Now, a point is kind of opposed. It's a piece of a line, and a line is a straight distance between 2 points that goes on forever. Now, a line is technically made up of an infinite number of points. Now, a line is considered the first dimension. So, these are really, really big points that we've drawn. So again, they're not actually this size. It's just the thought or the idea that X is here and Y is here. These locations, not these circles. Okay, again, a point does not have a shape to it. It's not a circle. It's just a spot. So this spot X, this spot Y, this straight distance between them is called the line. Notice this line has an arrow going in left and right, meaning it goes on forever in either direction. So if it goes on forever both ways, that makes it a line. Now the line is called the first dimension because you can travel 2 ways across it. On this line we can go left in this direction, we can go right in this direction. Right? So we have a left-right dimension to us. So this is the first dimension. Remember, point is like the 0th dimension, there's nowhere to go. Line is the first dimension. You can go left to right across this line. Okay, now if it takes a lot of different points to make a line, in fact we can, if we want, we'll show that. Here's a point, here's a point, here's a point. Use some different colors. This green one is almost right there. This one's separated. This one's way over here. We got a blue one that's literally like on top of those two. It almost covers it up. And then a bunch of other little blue ones that, again, they're almost touching each other. There's so many different points on this line, and they are so, so close together. It's basically just a group of an infinite amount of points running in a straight line. That's what we mean by line. Now, if you have a bunch of these lines together, they would make what's called a plane. Now, a plane, you can basically think of it as just flat land. It is a 2-dimensional space that has both an up and down directions and the left and right directions. The easiest thing to think about is just a flat piece of paper. So this kind of looks like a plane here. The difference between a real plane and a piece of paper is that this should go on forever. It's not going to stop at these edges like this piece of paper looks like. This would technically be a flat space that goes on everywhere upwards and downwards, and then left and right as well. That would be a plane. It's the full flat land for you to be on. Now we can put points on this plane. We can also put a line going across it. Now we can also put a line that maybe isn't on that plane. Okay, maybe it comes and then it cuts through and then comes out the bottom like this. Okay, you have to think of it as, again, if this was a table and then you were putting a pencil down through the middle of it, okay, that line would not be in this plane. but a plane is just that flat surface that everything else lands on. Okay, so point, line, and plane, those are going to be our three undefined terms, and we use those to define everything else. So, again, going on with some more of our building blocks here, a segment. So when we have a line segment, it's going to look something like this. Notice we have A and B. These are points, and we've drawn them really big. Remember, point doesn't actually have a size. It's just a location. So when you draw a segment, you want to label it, you would call this segment AB. That's what this little bar across means. It means segment AB. Notice there are no arrows on the ends of this segment. It just stops. So segment AB, it's a finite piece of a line that stops at two endpoints. Segments do have a length. So because it stops at this point and stops at this point and doesn't continue on, this is called a segment. And if you want, you can take out a ruler or something and you can measure this segment because it does indeed have a certain length to it. Now that's a little different from a ray. They look very, very similar, but a ray, we call this one ray DE. Ray DE, it's a piece of a line that starts at one endpoint and continues on in one direction. Rays have no length. Now this one, again, we can see it starts here at D and then continues on in this direction forever and ever and ever and ever. Okay, so because it goes on forever in one direction, you can't really measure it. So there is no length for a ray. Now we always define a ray. We call it ray DE. Make sure that you start that when you're labeling it DE, you start at the starting point. We go D to E, and we also draw that arrow in the direction that it's going. So ray DE means it starts at D, goes on to E, and continues on forever. Remember, that's just a piece of a line. It's not the whole line because we don't have this extra arrow part over here. If we did, then it would just be a full line. So segment, part of a line, ray, part of a line. An angle is then two different rays put together. So it's two rays that start at the same endpoint. Okay, and that's called the vertex. So in this case, Q is our vertex of the angle. Now we can name it a couple different ways. We can call it, I'm going to get rid of this, we can call it angle, that's what this little symbol means, angle PQR. So going from P to Q to R. Or we can call it angle RQP, RQP. Or in this case, we can just call it angle Q. Now notice in all of those, Q in the middle, or Q alone, you always put the vertex, that middle piece, in the middle when you are naming it. Now we can call this one Q because there's only one angle coming off it. But if I were to draw another ray coming off of it and I called, let's put a point here and call it S. Well, I can no longer call this green one that we've been looking at, I can't call this angle Q because we don't know if we mean this green angle Q or maybe this blue angle Q or maybe even this yellow, the really, really big angle Q. So we can no longer call it angle Q because there's all these different things coming off it. But as long as there was just, I'm going to get rid of some of these, as long as there's just these two rays here, you can call it angle Q. That's fine. Now, these angles will also always create our corners, kind of the edges of different shapes. And these can also be measured. Now, we normally measure it degrees. You might also see them measured in radians, but you can measure kind of that distance from here to here. That would be your angle measurement. All right, let's go over a couple more terms. Collinear, two or more points that happen to be on the same line. So 2 points will always be considered collinear. If I have 1 point here and 1 point here, I could, if I wanted to, draw a line that will go through those two. Okay, so because I can draw a line that's going to go through both of them, those would be considered collinear. If I had point here, and point here, again, those would be collinear because one line will go through all three of them. Now, if I had 3 points like this, 1, 2, and 3. These are not collinear, because if I try to draw a line that goes through these two, it's missing that other one. If I try to go through a line that, well, I would have to come down here, go through these two, it misses this one. So things are only collinear if they're in the same line. Now again, any 2 points will always be considered collinear because you can draw a line between the two of them. So then, of course, non-collinear basically just means 3 or more points that happen to not be on the same line. Now I said 3 here because, of course, 2 will always be in the same line. You can always make a line between 2 points, so 2 points will have to be collinear. If you have 3 points, I showed you the example up here, then it can possibly be non-collinear. Coplanar. Again, that's kind of similar to this collinear idea. Coplanar just means they're in the same plane. So 3 or more points that happen to be on the same plane. Now, instead of drawing a little example, I want you to think of if you had 3 marbles and you placed them on a table. So 1, 2, 3 on this table. I guess I am going to try to draw it. Now, these 3 are all on the same flat surface. So these are coplanar. But if you had a 4th one way up here that you held above, so it wasn't touching that table, now these are no longer coplanar. Okay? If you think about it though, if you were to place a pencil on this table, you think of that as a line, that line would also be coplanar. It's on that same flat surface. But if you held the pencil above the table, now that line is not coplanar. It's not in the same plane as these ones anymore. So collinear, same line. Coplanar, they are on the same plane. That's kind of what those ones are getting at. That's what they mean. Let's get rid of some of these. Non-coplanar, same thing. 4 or more points that happen to not be on the same plane. Now again, when I say points, that could also be lines. As long as the lines or the points or whatever you're using are not on the same plane, on that same flat surface, they are non-coplanar. A postulate is an assumed truth, and we'll go over a few postulates. These cannot really be proven, but we just kind of know that they're true. Okay, it's kind of like when you're looking through the dictionary and you're thinking, how do I define the word the? Well, it's hard to define the. It's kind of one of the first words that we think of. So all our other definitions are coming off of the word the. All of our definitions or our ideas in geometry come from postulates. On the other side, a theorem is a proven statement. It's going to use those postulates up here, logic, reasoning, different explanations. You're basically going to prove a new statement. So using all of these assumed truths, this will define something for sure. Once you've proven a theorem to be true, you can use it to prove other theorems. Parallel lines are just coplanar lines that do not intersect. So notice that this does say they are coplanar. They're in the same plane, in the same flat land, they just don't cross each other. Perpendicular lines are lines that may or may not be coplanar, so they don't have to be in the same flat surface that intersect at 90 degrees. So again, you can think of, here's your table. You're laying a pencil down on it, and then another one comes straight down and hits that pencil. That would be a non-coplanar perpendicular line. They intersect at 90 degrees. As long as this is coming straight down, that would still work. And also, there are skew lines. These are just lines that do not intersect, and they are not coplanar. So by that, if we have a table, you put your pencil down, and you hold the pencil way up here, sideways. So these two lines, they will not intersect, but they're also not in the same plane. Those would be called skew lines. The 6 postulates of geometry that we'll talk about just say a line contains at least 2 points. Again, we just kind of assume that to be true. There are always 2 points that we use to define a line. So line AB or line CE, something like that. So those 2 points are definitely in the line, so a line must contain at least 2 points. The intersection of 2 distinct lines is a point. If I have one line here and one line here, that place where they cross, we would consider this a point. Shouldn't be too crazy. The intersection of 2 distinct planes is a line. Again, think of 2 pieces of paper that you put right next to each other, and they touch. The area that they touch, that is considered a line. Through any 2 points, there exists exactly one line. If I have 1 point here and 1 point here, well, there's only one line that I can draw that will go through 2 of them. And let's see, for any 3 non-collinear points, there exists exactly one plane. So again, 1, 2, 3 different points. There's really only one sheet of paper that I could put, oops, I covered up that one, that I could put that would touch, just touch, not really go through. It just has to touch these 3. And lastly, for any 2 points in a given plane, the line that contains those points is also in that same plane. So if I put this point and this point in this plane, and then I connect these 2, oops, kind of missed them, but let's say I hit them, this line has to be in this plane, has to be touching or right on that flat surface. We're going to go over some examples in the next video then.